So can we do like that? Like the stored form is also glycogen and the consuming form is also an glycogen. Does it directly move here? No, no, no way, no chance. Why? Because this glycogen is entering through your digestive system. Okay, it's through your digestive system. So one digestive system should attach to your circulatory system only in your intestine, because I think you might have know this is a proximal convoluted tubule and distal convoluted tubule. This pipes has been surrounded with the capillary tubes. Okay, so this is the thing here. So by this, your digestive system product should go on to the circulatory system. Okay, should go on to the circulatory system. So for that, it need to move till your intestine. But if you are noticing, mouth is much more larger than your esophagus, then esophagus is larger than your stomach opening. I'm not saying stomach opening. Stomach, it can deposit, so it's large. Then stomach, intestine is too small. It's too small. Though the food has to reduce its size. So that's why it's showing a breakage. So okay, fine. If it is of large intestine, does it possible? There also chances is less. Why? Because the blood capillary are very small. So if you want to transfer the intestinal to the blood capillary, it should be lesser than the size of your capillary. So we can't directly forcibly pushing your polysaccharides inside your capillary. That's why it should convert from your large molecule to then small. Okay, that's a mechanism. This is called a mechanism of carbohydrates. Okay, then it will move on to the intestine, and at finally we should know how it will convert. Like this is your glucose molecule. So how we'll get an energy? So this is the formula. C6H12O6 is your glucose. So why we require oxygen in our respiration? Because we need to break down the glucose molecule. So that requires an oxygen. So that give you, we are releasing carbohydrates, right? So here the metabolism release the carbohydrates with water molecule. If you are not drinking continuously water, then also your body is not dehydrated because of these water molecules from the metabolism, and it will release the heat. This way gives you the heat representation minus 2850 joule per kelvin per joule. So this much energy you can expect from the one molecule of glucose. Okay, so one molecule of glucose will give you that much of energy. Are you getting my point? This is called it as sources of your carbohydrates. Then biological function. Biological function, what it will do? It will give energy. It will give, I'll write biological significance. Okay, biological significance. So first thing is your okay skeleton joints. Skeleton joints. What it will do? It will make an fibric structure called lubricating agents. So that is made up of carbohydrate composition. So it will help you to hold the two bones by an ligand, that is lubricate ligands, and it's used in the it's in the presence of your DNA and RNA, like a ribose. Ribose means 5-membered ring. Okay, ribose we are using. So that is deoxyribose nucleic acid and a ribonucleic acid. So RNA and DNA is present. Okay, fine. Then it is used as a drug. Okay, it's used as a drug for the streptomycin and gentamicin, streptomycin, streptomycin, and gantamycin. Streptomycin ಗೊತ್ತಲ್ಲ ಎಲ್ಲರಿಗೂ. We are using it of streptomycin and gantamycin. So, and it can be used in the form or in the sources of uh, carrying protein and lipid. Protein and lipid. Okay. And it's also used for the cell wall complex. Cell wall complex. Okay. I'll repeat the significance of biological significance of carbohydrates. It's used for the binding of skeletal muscles, skeletal joints. It's present in the RNA and DNA as in riboxy, and it's used as a drug in streptomycin and gentamicin. Then it's used to carry the protein and lipids, and it's present in the cell wall too. Okay, finish. So from this we are done with the carbohydrates. Now we need to move up our session to our next, that is protein. So if you're having any doubt, we have 10 minutes. So you do one thing. If you have any doubts regarding your carbohydrates, you can ask me. If you have any doubts in your carbohydrates, you can ask me. Gokul asking one thing. Does our body be dehydrated when even if we drink water, ma'am? Body get dehydrated when the body temperature or atmospheric temperature leads to more. Okay, when the body temperature or atmospheric temperature rises by 10 degree, it will decrease the body temperature, body water level of 2%. So actually our body 78% is made up of water. So we are seeing it's like we don't have water, that's why we need to drink. But just think one thing, we might have drink only 3 liters, maybe minimum 3 to 4 liters, minimum, not like we used to drink 3 to 4 liters, but our body metabolism requires more water, minimum 7 to 8 liters we require. And we used to pass our water in the form of urination, so there also we loss of water. So to balance out that way, we'll get that much of water. So we drink and we'll pass where the body can store the water. So that water is given by your metabolism pathway, that is called metabolic water. So that will present or originate in your metabolism, and it will utilize by your metabolism. It doesn't come or out. Okay. Srujan asking one thing. Ma'am, OS MO regulation in metabolism. Yes, that is called water balancing. We used to call it as water balancing. Okay, shall we move on? Anything apart from this? Anything to ask in your carbohydrates? Okay, then I'll move further. You have one work you need to do. That is, you should write 20 amino acid structures with their naming and symbol. 20, write it down. This is your assignment. Assignment fetches your marks. Okay, assignment fetches you at marks. Just a second, I'll take the attendance and I'll open my screen.
So it's Kiran, Chaitra, Gokul, Harshita, Mohat, Harshita V, Hemant, Kesi, Hitesh Nagal, Jyotsna, Kavya, Kirtana, Meenakshi, Meghana, Fani, Meghana, Manjunath, Mohammed, Nandita, Nikhil, Yashwant, Prajwal, Pratik, Rakshita, Sujit Ali, Shivkumar, Srijit CS, Sneha, Sujan, Suchitra, Vandana, Vijay, Vishakha, Yashaswini, Pratap. Pratap, Yam is your friend or sir?
Okay, fine. So that is your assignment. So you need to write and 20 amino acid structure symbol with name. So next we'll move on to the further introduction of your protein. So what do you mean by protein? Why we require protein? What's the usage of protein? Whether it is that much having the important in our daily life or not? So this and all the question you need to ask by yourself while starting and any concept. Okay, why we need to read? What is the use of it? Why we required? How much it required? Okay. So first, protein is made up of amino acids. Protein is made up of amino acids. So as we read, the carbohydrates is a composition of monosaccharides, that is sugar units or glucose. So same like that, protein is a big and bulk thing. It having an composition or it is made up of a small component that is called amino acids. Okay, that is called amino acids. So you can say like you can get the reverse question also. What do you mean by amino acid? It's a building block of protein. So what do you mean by amino acid? It's a building block of protein. You could have get the question of what do you mean by protein or what do you mean by amino acid. Both you should write in a reverse way. Okay, fine. Next question. It is present in your living being. Living being. So you can say it's a presence in your living system, and it is very essential. Essential. What do you mean by essential? It should require. It should require. Without that, we can't do anything. That is a essential component. Why it is essential? For the growth. Why it is essential? For the growth of the body, for the development of the humankind, we require protein. We require protein. Okay, where does that word derive from? That word derived from the Greek that is called Proteos. 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 It means to say first. First. Proteos means first. So this protein word is derived from the Greek that is called proteos. Proteos means to say first. So the component or the first required thing for the body development that is called as protein. Okay, that is called as protein. Then what does the protein made up of? Composition. What does the protein made up of? Yes, as I informed you, it is made up of amino acids. It is made up of amino acids. So amino acid having an three groups, okay, three groups that we should write the carbon center, carbon having four valency. One side it having carboxylic group, the other side of opposite to your carboxylic group you have amino acid group, and this is functional R group and this is H group. So your carbon is a main sources here. It having four valencies. One is filled with the carboxylic group. Here amino group. This is functional group. This is hydrogen. This is not group. This is single hydrogen. So the four components will made you one amino acid. This all remains the same for all 21 amino acid we have. This all same, these three groups, H group, amino group, carboxylic group remains same for all, but this R group will changes. If it is changes, will give you an different carbohydrates. Sorry, different amino acid. Sorry, different amino acid name. Okay. So then this is your introduction. We'll continue it tomorrow. Actually, it's running out of time. That's why I'll finish it up. You have much more introductory for this.